Hi everyone. In this video, we will talk about derivatives and increasing and decreasing functions. Now, let's see the definition of increasing and decreasing functions. A function is increasing in an interval if, as x increases, y or fx also increases. It simply means that as the value of x increases from -10 to -5 to -1, and then becomes 1 and 2 and 3 and 4 and 5, the value of y is also increasing, right? At -10, y is a big negative value of -17. And at -5, the value of y has increased and become -7. At this point, which is between -1 and -2, the value of y is 0. At 5, the value of y is 13, and so on. So as the value of x is increasing, the value of y is also increasing. That's why this straight line graph is an increasing function. Also, what is the gradient of this graph? Is it positive or negative or 0? We see that the gradient is positive because it's a line which is going up from left to right. So an increasing function has a positive gradient. Let us now take a look at another graph. So now we have this graph of another straight line which is going down. So what do we see? The value of y. What happens to the value of y as the value of x increases? In this function, we see that as the value of x is increasing, so x is over here -20, the value of y is somewhere -22, is 22. The value of x increases from -20 to 0, but the value of y has dropped. It has become less. Further on, as x increases, it becomes 10. The value of y becomes even smaller. It becomes almost -7. As x increases to 20, y becomes even more negative. So as the value of x is increasing, as x is increasing, the value of y or fx is decreasing. Also, it's a line which is going down, so the gradient of this line is negative. So what we have seen just now, in the previous question, we have seen that as the value of x is increasing, the value of y is also increasing. So this is an increasing function. And its gradient is a positive value. Here, it's a decreasing function, and this function has a gradient which is negative. Let us examine another function. So now we have a quadratic graph, a parabola. Now what do we see in this parabola? We see that in this region, from here up until the vertex, as x is increasing, y is decreasing, right? We can see that when x is -20, y is 33. When x is -10, y reduces to almost 10. So it's a decreasing function in the interval when x is less than 0. In this interval, when x is less than 0, this function is a decreasing function. But when x becomes greater than 0, as the value of x increases, the value of y also increases. When x is 10, y is 11. When x is 20, y is 34. When x is 30, y has another bigger value. So in the interval when x is greater than 0, this function is an increasing function. So what we see is a function can be increasing or decreasing over a given interval. It may be increasing over a certain interval, but decreasing over another interval. But now let's talk about the gradient of these functions. If I take the interval when x is less than 0, where this function is the decreasing function, and try to draw a tangent on this line at this point. So if I draw a tangent at this point here, this tangent line is a line which is going down. So it will have a gradient that is negative. If I take another point in this interval, let's say I'm taking up another point here and try to draw a tangent here. So if I draw a tangent at this point here, again, this tangent is a line which is going down, so its gradient is negative. And we know that the gradient of a curve is equal to the gradient of the tangent drawn at that point. The gradient of a curve at a point is equal to the gradient of the tangent drawn at that point. So if a curve is decreasing function in an interval, its gradient will also be negative. And gradient of a curve is given by dy dx. Dy dx is negative for a function that is decreasing. For decreasing functions, derivative dy dx is less than 0. However, if I take the increasing interval of this function, when x is greater than 0, this function is increasing. And if I try to plot the gradient, the tangent at any point over here, what I see is the tangent line is a line which is going up. So if a tangent is a line that is going up, that means its gradient is positive. If the gradient of the tangent is positive, that means the gradient of the curve is also positive. So let's say I take this point here. At this point, if I try to draw a tangent line, again, this line is a line which goes up and has a positive gradient. So if the gradient of the tangent is positive, that means the gradient of the curve is also positive at this point. So dy dx, that means the derivative of the curve will be positive for increasing functions. More precisely, on an interval where the function is increasing, its derivative is positive. Let me write this. In an interval where the function is increasing, its derivative dy dx is positive. And in an interval where the function is decreasing, its derivative dy dx is negative. So now we can use the idea of dy dx as positive or negative to determine the interval over which a function is increasing or decreasing. Let us apply this in a question now. So let's see this scenario first. In this situation, we have a cubic curve. So this cubic curve is increasing from x. As we see over here, this function is increasing in the interval between this value of x, say this value at this value of x, to this value of x here. It's an increasing function. But between x here to this value of x here, to this turning point, what we see is this curve is a decreasing function, so its derivative will be negative. So this function is decreasing in this interval here, between this value of x, between x from this value to this value. It is decreasing. And again, the function is increasing from x is equal to this value to whatever the value of x is over here. So in this region, the derivative dy dx should be positive. In this region, the derivative dy dx should be negative. And again, in this region, this part of the curve, the derivative dy dx will again be positive. Let us apply this in a question here. I have a function fx is equal to negative x cubed plus 6x squared minus 10. Determine the values of x for which fx is an increasing function. So if fx is an increasing function, that means its derivative in that interval is going to be positive. dy dx will be positive. So let's find the derivative of this function first. Fx is minus x cubed plus 6x squared minus 10. So f prime x will be minus 3x squared plus 12x. So that's the derivative dy dx. And if the function is increasing over an interval, then the derivative should be positive. Let us factorize this. So my 3x and I get minus x plus 4 is greater than 0. So this is a quadratic whose roots are x is equal to 0 and x is equal to 4. It's a quadratic which opens downwards since the coefficient of x squared is negative. So here we have x is equal to 0. Here is x is equal to 4. Where is this function greater than 0? It's greater than 0 when x is between 0 to 4. So the values of x for which fx is an increasing function is when x is greater than 0 but less than 4. So let's quickly go over it once again. Determine the values of x for which fx is an increasing function. If fx is an increasing function, its derivative should be greater. Its gradient function should be greater than 0. So the derivative, the gradient function is minus 3x squared plus 12x greater than 0. This is a quadratic. That means the shape is a parabola opening downwards since the coefficient of x squared is negative. So we want that this gradient, this parabola should be greater than 0, and it is greater than 0 when x is between 0 to 4. So the function is an increasing function in the interval where x is between 0 to 4. Let's see one more question. Consider a function with domain x greater than a or less than b and less than b, and the diagram is given to us. The following diagram shows a graph of f primes. This is the graph of f prime, the derivative function, the derivative of f. The graph of f prime, the derivative of f, has x-intercepts at p and 0 and t. And there are local maximum minimum points. Now, my part A of the question says, find all the values of x where the graph of f is increasing. If the graph of f, if fx is increasing, that means its derivative in an interval will be positive, right? So what we know is, if a function is increasing, then f prime, its derivative should be positive. Now, in this diagram, between what interval of x to what interval of x do we see f prime as positive, having a positive value. We see that it is positive in this region, right? In this region, f prime is above the x-axis. That means it is positive. After 0, it becomes negative. So the graph is increasing in the interval when x is between 0, when x is greater than p, but less than 0.